Hello, and welcome to the Fireside Chat. Today we are discussing migrating your big data applications from on-premises data center to the AWS cloud. My name is Abhishek Sinha, and I have the pleasure of welcoming Rahul Pathak, who is the General Manager of 6 different analytics services at AWS.
Hey Abhishek, how are you?
Doing well, sir. How are you?
Doing great. It's great to be here.
Thank you for joining us. So Rahul, tell me a little bit about yourself, what services you manage, how did you get into AWS, and a little bit about your journey.
Sure, absolutely. So I currently am the GM for 6 of our services, as you mentioned. TimeStream, EMR, Athena, and then our managed blockchain service, Neptune, which is our graph database service, and DocumentDB, which is our MongoDB-compatible document database. Been here about 8 years, joined as a product manager, and have worked on caching, relational databases, launched Redshift, and then picked up product and engineering for a suite of services. And prior to AWS, I've been in tech startups the bulk of my career and wanted to come work on infrastructure, and AWS seemed like the best place to be. So that's how I got here in November 2011.
Awesome. So you said EMR is one of the services that you manage. Tell us a little bit about what EMR does and who are your customers and generally about the business.
Absolutely. So EMRs are managed Hadoop and Spark offering, which provides the latest in open source big data analytics technologies in a managed environment. And by that I mean we take care of provisioning clusters, scaling them, and allowing customers to get their work done at as low cost as possible. And customers are folks really come in 2 camps. They're companies like FINRA and Intuit that are migrating from on-premise Hadoop clusters onto EMR for better cost and better scale. And we've also got cloud-native companies like Airbnb that are looking to get more efficient and get more capabilities from their analytics.
Awesome. So let's focus on the first set of customers who are who either had a Hadoop cluster or have still running a Hadoop cluster on-prem, and they may run like a variety of workloads like Hive and Spark. Why are customers migrating such workloads to the AWS cloud?
It's a great question. So if you think about clusters on-premise, they're typically a fixed resource. You have to share them across. They need to be always on. And there's a lot of extra cost and redundancy baked in. So for example, you have to replicate your data 3 times to make sure you never lose it. And you also have to ensure that you govern how people can access data so you don't interfere with mission-critical jobs. Now, when you move to the cloud, what you get is the ability to decouple your compute and storage. And so we recommend that customers move their data off of disk drives onto S3, which is our storage service. And this gives them very low cost, very high scale, great availability and durability for their data. The other big advantage that customers get is that now they can decouple their compute clusters from their data storage needs. And so you can run multiple clusters at the same time, so different teams can be running different types of technologies like Spark or Hive or Presto without interfering with each other. And you get the ability to scale up your workloads when you need to, and scale them down and even shut them off when you no longer need to be doing any work. So customers typically see a 60 to 70% savings when they make the move. And because EMR always provides the latest of what's available in open source, staying current with the best-of-breed technology becomes a lot easier than if you have to upgrade a large monolithic system.
Awesome. And does it work across the range of applications from Spark and Hive? Mostly customers have a wide variety of applications.
Absolutely. So we offer, I believe it's 17 at this point, open source analytic frameworks and applications out of the box. And we work very hard to stay current with open source. And for major applications like Spark and Hive and HBase, we try and stay within 30 days of new releases in open source. So customers always have access to the latest. And it makes it easy for them to drop in their jobs because the APIs are fundamentally the same as the ones they're accustomed to.
So arguably, it's much easier to migrate your on-premise workloads to the cloud because you're not really drastically changing your applications.
That's right. Your applications remain largely the same, and you get all of the benefits of better scalability, lower cost, and more currency in terms of the latest versions of the applications that you might be running.
Fantastic. So decoupling of storage and compute and using S3 as a data store seems to come out as a theme. It also seems like this is central to AWS's data lake strategy. Can you talk a little bit more about what AWS's data lake strategy is?
Absolutely. So what we've seen over the years is that there's been an explosion in the number of data formats that are out there. So it's no longer just tables coming out of databases or ERP systems. You've now got things like log data, semi-structured data like JSON. You've got social media. You've got IoT. So the variety and volume of data has exploded, and the classic systems of data warehouses aren't sufficient. And so what we've been recommending to customers is that they should move their data to S3, use a service like Lakeformation, which just went GA, to define their data policies and permissions, and then decouple their analytics and run any kind of analytics, whether in EMR or in Redshift or in Athena, against that data. And so this maximizes their ability to scale and their flexibility, because they can use the best of breed of analytic technology without having to re-platform their data.
Nice. Are you seeing a lot of your customers who are evaluating a move to the cloud also reevaluate their architectures and look at data lakes as to the migration of cloud leads them to the migration into a data lake?
We are. And if you think about it, customers' analytics infrastructure on-premise typically has been monolithic and expensive, and customers have made choices to throw away data rather than scale their infrastructure. So when they think about migrating to the cloud, they have an opportunity to modernize what they're doing with their data warehousing and analytics and big data. And that naturally leads them to evaluate data lake-based architectures, because they get the best of both worlds. They get full flexibility, costs that are low enough to keep all the data that they ever could want, which becomes especially important in machine learning type scenarios where you might want to go back in time and retrain a model. But now they can keep everything and then run any analytics they need without interfering with each other. So you could have a group running Spark to do data science or machine learning, and you could have another group using Hive to do production reporting, and they don't interfere with each other at all.
Awesome. So how does EMR fit into this data lake story?
So data lakes have been part of EMR's story from the beginning, and we right when we launched the service, realized that having data on S3 would be a huge advantage for customers. So ensuring that EMR can run the best of open source directly against data in S3 without having to load it into HDFS has been core to EMR's strategy and feature set.
Wonderful. Let's say I'm a new customer and I have a large on-prem deployment at the moment. And I run Hadoop and Hive and Spark and a mix of these environments. How do I start my migration journey?
So what we've done is we've put together a pretty comprehensive migration guide. It's about, I think, 140 pages at this point, based on best practices that we've learned over the last several years working with customers who have made the same migration. And we talk a lot about the various stages that you have to explore, things like how do you move your data to S3, how do you set up permissions, authentication, authorization, how do you ensure that you can set up data practices that allow you to upgrade easily. So that's a comprehensive guide which distills the best of advice that we have, and would recommend taking a look at that. You also have an opportunity to sign up for a free 2-day workshop where you can work with us to assess what your migration would look like, and we can figure out how to prioritize it and help you sequence it. And we'll be providing information on how you can get these resources. And there's no charge for either of these.
Wonderful. So customers can just go and download this guide, or they can sign up for these workshops.
Exactly. And then we also have a lot of content, for example, from our last reInvent, where customers talked about how they migrated and some of the best practices that they discovered along the way for themselves.
Fantastic. So give us a little bit insight, because you talk to customers so often. What are the big architectural decisions that they're making when they're moving from on-prem workloads to this decoupled storage and compute model, which seems like is a beachhead for the data lake?
So there's a few things customers need to think about. One is that at a fundamental level, they've been used to thinking about the cluster as a very precious thing that only a few people can touch, that has to be divided amongst whoever needs it. Whereas when you move to a cloud environment with this decoupled architecture, two things happen. One is you can actually make your cluster smaller because you don't have to size it to house all of the data, because all of that data lives in S3 and it can grow infinitely at much lower cost than keeping it all online in your cluster. The second thing is that you no longer have to think of a cluster as a fixed resource that only a few people can access. Now, any team that needs access to a cluster can actually self-provision what they need in a governed way. You can allocate costs to that team, and each team can go at their own pace. And so this notion of decoupling is one of the most powerful things that a customer can do to really get the benefit of this flexibility.
Wonderful. What about if I'm running the same architecture on EC2? Maybe I'm using just plain vanilla Hadoop or Spark and running them on EC2. Does EMR provide an advantage there?
It does. I mean, you already get a lot of benefits from EC2, but those fundamental architectural limitations of running clusters on instances still remain. Fundamentally, your data is still on local disk, it's still replicated. And so if you're moving to EMR, you get a decoupled environment with managed clusters that are automatically integrated with things like auto-scaling and the spot market, where you can get up to a 90% discount on EC2. Now, you could write a lot of software to do this all yourself, but we've made it available to you out of the box in EMR.
Fantastic. You make hundreds of releases per year. Can you tell us about some of the recent product releases that might be important to on-premise customers or customers who are running Hadoop on Spark on EC2 that will make this migration to EMR much more easier or make it much more beneficial for them?
So there are a few areas where I think that we've had some really significant releases. So one of them has been around Spark and performance. So if you look at EMR release 524, that's over 10 times faster. I think it's about 16 times faster than EMR 516. And then the next release, EMR 525, is faster still. And we've invested a ton in optimizing Spark performance so that you can just drop in your jobs and have them run faster without having to do anything. And in this environment, because you're paying by the second, a job that runs faster is also a job that's cheaper.
Yes.
So that's one big area of investments has been around performance. The second has been around elasticity. So auto-scaling, the ability for your clusters to expand when there's more work and shrink down when there's less, again, helps optimize your costs. And then the third big area is in security. So with lake formation, which we just went general GA with, lake formation allows you to assign very granular controls to your tables and columns for your data in S3. And we've integrated this with Spark, so it's available in beta now. So you get all of the benefits of EMR Spark performance, differentiated Spark performance, with the ability to get very granular control on data in your data lake and the ability to audit and see who did what with which piece of data. So going back, it's really about performance, driving down your costs, and improving your security. These have been the big areas of releases that I think are worth paying attention to.
Fantastic. Can you share some customer stories about and learnings about when customers have migrated from on-premise clusters to the AWS cloud?
Sure. So one great example is FINRA. They regulate all U.S. equities, and they process about 125 billion or more market events per day. Now, they started off on-premise. They migrated to S3, did a great job of decoupling their data from their compute layer. And they started off with Hive on MapReduce several years ago, running on top of AWS. And some of the benefits that they've seen have been the ability to run faster, so they get better performance than they used to on-premise at lower cost. They're heavy users of Spot. It's probably saved tens of millions per year in their overall cost profile. The second big benefit that was sometimes it's a bit more subtle is that they've been able to upgrade technology generations 3 or 4 times in the last 4 or 5 years. So they started with Hive on MapReduce, they moved to Hive on Tez, which is a faster execution engine, and now they're moving to Presto and Spark. And so this technical agility that you get by being able to keep your data in open formats in S3 while still evaluating new technology and adopting it when it's available has been a huge advantage for them as they try and keep bad guys out of the market and enforce compliance. Another great example, probably many of you have kids that play Fortnite. So if all of Fortnite's analytics runs on AWS, They're actually an example of a cloud-native company, but they're processing, I believe it's about 30 or so petabytes of data in S3, and that's growing pretty dramatically. And then another company, Airbnb, they were running out of scale on their fixed Hadoop cluster, and so they migrated to a model where they're able to put their data on S3, scale out as they need, and then take advantage of Spot to drive down costs without compromising on the amount of data they can process and the performance that they can achieve.
Fantastic. Well, let me also look at if there are any questions on the chat.
Sure.
All right, here's a good one. You recently released Lake Formation, so tell us a little bit about Lake Formation and how EMR integrates with Lake Formation.
So Lake Formation is a service that makes it easy to manage, set up, secure data lakes on S3. So as I mentioned earlier, we believe that customers bringing their data in open data formats to S3 maximizes their analytic flexibility. And what Lake Formation does is it makes it easy to discover your data sources either in databases or elsewhere on S3, register them in your data lake, transform your data if needed, and then bring that data into the Lake Formation data catalog. Now, in the Lake Formation catalog, you have the ability to define a security and data access policy that lives with your data. And so you can say which users and groups can access which tables and columns. And regardless of the analytics service they use, whether it's EMR and Spark or Redshift or Athena, those policies are enforced. And so you have a central place where you can see who's accessed your data, what permissions they have, and it makes it very easy to administer your data lakes. And then the third piece that Lake Formation provides is a set of machine learning-based data transformation jobs. So it allows you to remove duplicates from your data. It allows you to link data that's meant to be linked together. And you have the full capabilities of Glue, which is our ETL and orchestration service for data management. So that's Lake Formation. And where EMR fits in is that we've invested heavily to ensure that EMR integrates seamlessly with Lake Formation. So you can have data in S3 protected by Lake Formation, and then EMR applications integrate with that. And we've started off with Spark, and then we'll be adding others as we go.
So is the Lake Formation catalog the same as the Glue data catalog?
Yes, essentially Lake Formation is built on Glue, and those catalogs integrate, and you can choose to seamlessly migrate from Glue to the Lake Formation catalog if you want to take advantage of those new capabilities.
Wonderful, thank you. We probably have time for one more question. We talked about better Spark performance. Can you tell us about how do you measure it? What are you doing in terms of the Spark performance, and is it better than open source, so on and so forth?
Sure. So we've been focused on measuring Spark performance in a number of ways, routine jobs, as well as looking at the TPCDS 3 terabyte benchmark. And as I mentioned, we've seen more than 10x gains in recent releases of EMR versus older ones. And then our next release, we're expecting another 20 to 40% gain on those benchmarks. And this is definitely faster than open source and at par or better than some of the proprietary offerings that are available. And what we've done is invested a lot in things like optimizing joins, reordering them, using Bloom filters to get more efficient, figuring out how to prune partitions better, and reordering how queries get executed in order to get the best possible performance. And so our goal is to really give customers a world-class experience when running Spark on EMR, and one better than they can achieve elsewhere.
So do customers need to change their Spark applications, or does it use the same API?
It uses the same API, so everything's compatible. You merely would drop in your job and configure EMR to enable all of these performance optimizations. And then starting in our next release, we'll have them enabled by default. So you should just be able to drop in your job unmodified and have it run faster with all the benefit of the investments that we're making.
All right. Thank you very much, Rahul. Thank you for the time that you spent with us today. That's all the time we have, folks, for today's Fireside Chat. Thank you.
Thanks, Abhishek, and thank you, folks.